Let's take some more examples on circular motion in vertical plane. We have a rope of length 2 meters. There is a point mass 4 kg, and this 4 kg mass is given a velocity u horizontally at the lowest point. When u is 5 meters per second, first case. Second case, when u is 7 meters per second. Third case, when u is 20 meters per second. All these three cases we need to find maximum angular displacement of this object. Now, pause the video, see your notes, how should we handle this question, and then come back and see the solution. Whenever you are given a question like this, first thing you need to know is this: when velocity at the lowest point is root 2gr, then it completes 1/4 circle. One-fourth. For the given question, let's take GS 10, R is what, 2. This is coming root 40 meters per second, which is, let's say, approximately 6 meters per second. We need to have an approximate idea. To complete 1/4 circle, velocity required at the lowest point is 6 meters per second, and velocity required to complete half or full circle, half or full circle is root over 5gr, which for this given rope, this rope length will decide what should be the minimum velocity to complete full circle. 5, g is 10, r is 2, which is coming 10 meters per second. To complete 1/4, you must have 6. To complete half and then full, you need to have 10 meters per second. But look at this first part. First part says u is what? 5. What is 5? 5 is less than 6. Which means what? When you give 6, it can just reach the 1/4 mark. That means when u is 5, when you take u as 5 meters per second, in this case, this object will not be able to reach the 1/4 mark. It will stop somewhere here. Once it stops, question says find out this theta. U is 5, which is less than 6. You cannot reach 1/4 mark. That means you are in the lower half. And if we are in the lower half, then at the extreme end, velocity should become what? 0. If v becomes 0, then we have the formula of v. And that formula is what? Root over u square minus 2gr into 1 minus cos theta. At this theta, v becomes 0. U is 5, G is 10, R is 2 multiplied by 1 minus cos theta. Solve this and you will get what? Cos theta. Now there is nothing left. Simply remove the root and you will get the value of cos theta. This is first part. Now, if you look at the second part says u is what? 7 meters per second, which is greater than 6. That means now it can complete 1/4 circle, but it cannot complete half circle. To reach this position, you must have a minimum of 10. But since you only have what? 7, it's not possible to reach this position. And therefore, what will happen? In the second part, the object starts from this position with u, which is what? 7 meters per second. It will reach and cross 1/4 mark, goes up, but cannot complete full circle, and therefore, after this point, after this maximum angular displacement following the circular path, it will further follow a parabolic trajectory. Now, as you are now in the upper half, at this point, velocity cannot be 0. What becomes 0? You know that. It's what? T. Right at this position, T becomes 0. That's the advantage of calculating these values in advance. 6. It's greater than 6. It's less than 10. And therefore, somewhere here, it will break the circular path and will follow parabolic trajectory. Our aim is to find what? This theta. We cannot use V. What we should use? T. What's the value of T? T is mu square by R minus of 2mg plus 3mg cos of theta. T, it has become 0. M, you don't need it. M. It gets cancelled. What's the value of u? 7. 49 square divided by 2 minus 2 into g 10. M is cancelled plus 3g cos of theta. Solve it and you will get what? Theta. This is your second part. And I hope you can all see third part is very easy. In third part, velocity at the lowest point is what? 20. To complete half or full, we need what? 10. And therefore, in this case, it will complete full circle. And therefore, when you give it u as 20, it completes full circle like this. And therefore, you can say that maximum angular displacement is what? 360. In this case, your maximum angular displacement, if you talk about one rotation, it will be what? 360. And after that, it will continue again and again and again. But for one turn, your maximum angular displacement is what? 360, because this u is greater than 10. this U7 is less than 10 but is greater than what? 6. This U of 5 is less than 6. What is 6? Root 2 GR. What is 10? Root 5 GR. That's how we handle questions like these. Hopefully समझ में आ गया होगा इतना part. Note down everything. Now look at this part. So far we did vertical circular motion with the help of a rope. And when you have the rope and you throw it with U, after an angular displacement of theta, its velocity becomes V, tension force is T, and we know all these things. Suppose instead of a rope, they give you a circular frictionless track. It's a frictionless circular track. And on this frictionless circular track, we have an object which can slide along the internal surface. Now if you throw it with some velocity u, this radius is r. Remember, there is no friction. Friction is what? 0. When this object slides along the internal walls like this, if these are the internal, this is the internal wall, then the object is sliding like this. In that case, when object is at this position, its velocity is again same v. There is a downward force of mg which is also present in this case. Now the role of tension force in this situation is played by the normal reaction force. This object and the circular track, this is the contact surface. And we know that at the contact surface always acts what? Normal reaction force. And normal reaction force acts such that it acts perpendicular to the contact surface and towards the body. So this circular track is pushing this block in this direction. That's your normal reaction force, and it's perpendicular to the contact surface, and therefore it is pointing towards the center. Role of tension force is now played by normal reaction force, and therefore you can do what? We developed a formula of T as m u square by r minus of 2mg plus 3mg cos theta. And the only thing you need to do is what? Replace this T with normal reaction N. N is same as what? T. You don't have to have a rope. Required centripetal force. For the required centripetal force, if you remember at this place, this angle was theta. We resolved mg in this direction, that gave us mg cos theta. This is the center. Towards the center, what is the net centripetal force? T minus mg cos theta as mg V square upon R. That's your centripetal force, mv square upon R. But for this case, you will simply do what? This is n, this angle is what? Theta. Again, you will resolve mg in this direction. Component of mg in this direction is m g cos theta, and this centripetal force therefore becomes what? N minus mg cos theta. N minus mg cos theta, which is what? M v square upon R. That's the reason you can simply replace T with what? Normal reaction force. Now once you do this, what other type of questions we can frame on this profile? We'll see that. But first, note down this transformation. Remember, it's a frictionless circular track. Note down this much, and then we'll see some examples on this part. Now look at these questions. We have an inclined surface, and then at the lowest point, this inclined surface becomes a circular track of radius r. The whole thing is completely frictionless. Inclined surface, let's say this angle is phi. An object of mass m is released from this height h. This height is what? H. There is no friction anywhere along the path. The question is, first part, find out minimum h so that object can complete 1/4 circle, and the second part, minimum h so that can complete half or full circle. Write down the question. Find out minimum h so that object can complete number 1/4 circle, number 2 half or full circle. Now pause the video, figure out how to handle this whole thing, and then come back and see the solution part. In the first part, we need to have 1/4 circle. For 1/4 circle, how will you handle this question? Look here. There are two easy methods. In first method, for the first part, we know that to complete 1/4 circle, this u must be root over 2gr. This is for 1/4 circle right here. And therefore, when you release the object, after sliding down at this point, its velocity should be root 2gr. What the first method says that this u therefore is root over 2gh. Question is done. What is root 2gh? From work energy we know that from height h, if you release something on a frictionless surface, then at the bottom velocity is always what? Root 2gh. Whatever be the value of phi, it doesn't matter. If this height is h, then velocity at the bottom is root 2gh. But question says that this root 2gh should be what? Root 2gr. And therefore we get h as what? R. First method for the first question. First method for the first question is done. Now look at the second method. When u is root 2gr, you know that object just reaches what? This position. And that's what question also says. We need to find minimum u so that it can reach this position. Important thing is, at this position, we know that velocity becomes what? 0. If u is root 2gr, after completing 1/4 circle, v becomes what? 0. If v is 0, then second method says, at this position, your kinetic energy is what? 0. What is potential energy? mg. What's the height at this position? From the ground surface. From this position, this height is what? R. So what is the gravitational potential energy? mgr at this location. Now, it was released from this point, and throughout there is no friction. And if there is no friction, we can do what? We can conserve mechanical energy. So what we are basically doing is we are applying COME. Now COME says that it's released from this position. What is kinetic energy? 0. What is potential energy? mgh. Done. mg cancelled. Your h is coming what? R. So what happened? Right here, total mechanical energy is in the form of potential energy. There is no kinetic energy. It slides down. At the bottom, there is no potential energy. It has become 0. All that energy is now in the form of kinetic energy. It again goes up. At this position, kinetic energy again disappears, and the whole energy again reappears in the form of what? Potential energy. And therefore, this height and this height, they both should be same, because at this position and at this position there is no kinetic energy. That gives you what? 2 methods for the first question. And I hope you can answer second part again with the help of these 2 methods. So do what? Pause the video, note down this whole thing, and then if you haven't attempted the second part, then go for it. Now, for the second question, we need to find u so that it can complete half circle. U so that it can complete half circle is, you know, root over 5gr. So, when this object slides down, velocity at this point should be root 5gr. That's your first method. U should become root over 5gr. But whatever happens, after it slides down a vertical height h, this velocity is always root over 2gh. What happens this point onwards has nothing to do with this part. As it slides down at this point, velocity will become what? Root 2gh. But to reach highest point or to complete full circle, you must have root 5gr. That gives you h as 5r divided by 2. G and G cancel the root sign, and you got h as what? 5r by 2. That's your first method. Look at the second method. Second method, again with the help of COME, conservation of mechanical energy. Now, let's apply conservation of mechanical energy between this point and this point, the highest point. When this object is at the highest point, first mistake which people do when they apply COME at the highest point, they consider V as 0. But you know that once an object has crossed the 1/4 mark, once it has crossed the 1/4 mark, there is no way velocity can become 0. It's not possible. For the critical case, for the minimum case, when it just reaches highest position, at the highest point, tension becomes what? 0. But in here, normal reaction will become what? 0 at the highest point. So, if normal reaction is 0, then you know that at the highest point, V is not 0, but is what? V is coming root over gr. We already have this formula as a result. So the highest point your velocity is root gr. Now let's apply COME. How do you apply COME? Starting position. Kinetic energy 0. What is potential energy? mgh. Kinetic 0. Potential energy mgh. At the highest point, what is kinetic energy? Half mv square, which is what? gr plus potential energy, which is mg, multiplied by height from this. What is the height from this? Diameter. What is that? 2r. This is coming what? 2r. 2 into 2, 4 plus 1, 5. And you get your h. Again what? 5r by 2. That's how you can handle this type of question with the help of direct result or using conservation of mechanical energy. Go down this much.